All right, you guys, today we are taking on the least square regression line. So sometimes we call that a linear regression line or a line of best fit. But regardless of what we call it, a good regression line makes the residuals as small as possible so that the predicted values are close to the actual data values. So if I'm being technical, that least square regression line, or LSR for short, right, in case you don't want to write this every time, right, it's the line that makes the sum of the squared residuals as small as possible. So to help you visualize what that actually means, we have two scatter plots here. Okay, they show data on Ford F-150 models, comparing the miles driven, that's our x-axis, the explanatory variable, and price, our response variable, on the y-axis. The least square regression line is added to each scatter plot. So here we see all of our data points and the residuals are drawn in. So our residuals are the difference between our actual data y value and the y value that the model predicted, so y minus y hat. So we should know that any of these data points up here will produce a positive residual. And then all of these data points below will produce a negative residual. Okay, so then if we take all of those residuals and we add them all up, the sum would actually be pretty close to zero, be just about zero. Okay, so if we focus instead on the sum of the squared residuals, so we're taking each of these vertical distances, okay, but we're looking at it as the residual squared. So over here, you can see that that vertical segment here, right, if we're squaring it, we're looking at it horizontally as well. So we're picturing it as a little box, as a little square. We're picturing it as the overall area that is the residual squared. Okay, we want to minimize the sum of the squared residuals as much as possible. That is our goal for a least square regression line. All right, so let's go through it in one big example. So in our example 1, does taller mean faster? So we're going to calculate the least square regression line with technology. So the table shows the height in feet and maximum speed in miles per hour for a sample of 7 roller coasters from the roller coaster database. So if we're looking at does taller mean faster, does height influence the maximum speed? So height would be our explanatory variable x, maximum speed would be our response variable y. So let me just write that out. So explanatory variable right, x. In this context, we're looking at height in feet, and we want to know, does it influence the response variable? That's our y, and in this context, that's maximum speed in miles per hour. Okay. So we want to make a scatter plot of this data and then describe the relationship. Do we see an association? If we do, let's identify the form, direction, strength, and any outliers. All right, so I know that we're looking at that question, does taller mean faster? So you could write that as a statement, that's fine. We know that our variables are height and maximum speed, so you just write that up top. The order for me really doesn't matter because you are labeling your x-axis and y-axis anyways. So I think I will leave it just like that. I'm going to say height versus maximum speed. If you flipped it around, it's actually more technical. It doesn't actually matter to me though. So height versus maximum speed, we're looking at height on the x-axis in feet. Right? Again, that's our explanatory variable. And then our response variable is maximum speed. And that's on the y-axis, miles per hour. All right, so I just built my frame, so I'm ready to go. So before I do anything, a few things that I want to check before I build my scatter plot. So I want to make sure I go to my stat plots. So second y equals. I want to make sure that I have only the first one turned on. So it's on. It's on scatter plot, list 1, list 2. What marking do you want, right? That looks great. I'm going to check my y equals right here, sorry, my function list, right? So second y equals was my stat plots. Y equals takes me to my function list. I want that to be totally blank, right? I don't want to have any other functions entered that are going to be added to my graph that I don't want. So if I did, I would just clear it out. Okay, so then I'm good. So I'm going to type in all of my data, height in the list 1, maximum speed in the list 2. I already have it typed in. Let me show you. So I would like you to catch up to me. So maybe hit pause, type in your data, make sure we match, and then unpause, and let's make our scatter plot. So here I'm going to quit out. There we go. And I want to make my scatter plot. So I'm going to do zoom 9, and this is what I come up with. So this is what the data looks like. I'm going to sketch that on my paper right now. Okay, so here is what it looks like. Again, in my calculator, that is what it looked like right there. Okay, so I'm just sketching that onto my paper. So how would I describe it? I definitely see a line, right? I can see a linear trend, right? Positive slope. So I would say that it looks pretty strong to me. So positive, strong, and linear. And if I stare at it, it looks like this data point kind of deviates from the rest of the group a little bit. That could be a potential outlier. When I think about what would be its influence on correlation, it would strengthen it because it's along that trend line and then far away from the rest of the group. So this point has the potential to add a lot of weight to the overall sum of the z-score products. So in that calculation, this outlier, this potential outlier, could strengthen the correlation. It could make it look like it is more of a perfectly straight line than it is actually. All right, so let me acknowledge that data point as a potential outlier. It was at 305 and 90. So 305 feet, maximum speed was 90. So here, remember that it was along that trend line. Which means that it has the potential to strengthen the correlation. Okay, so it has the potential to pull it closer to 1 than it really would be without that one data point. All right, so now we're going to use our calculator to find correlation and the least square regression line for predicting maximum speed from height. So correlation is the R. Least square regression line that we're using, y hat equals ax plus b. So I'm keeping in that familiar format because that's just slope-intercept form, just like how you learned it in Algebra 1 and in Algebra 2. And we're predicting maximum speed, right, that's our y, from our height, which is x. All right, the very first thing that you actually have to do is make sure that you check your catalog. Okay, I'm going to write all this stuff down, but I want to make sure that I talk you through it as well. So check your catalog. Make sure that your diagnostics are on. So your catalog is right here. Let me scroll up so you can see my buttons. So calculator, I have to hit second 0 to get to my catalog. And then when I pull it down to see my screen, you can see catalog. I have to scroll down to diagnostics on. So I'm going down for a while until I get to my D's, and I'm looking at diagnostics on, right there, diagnostic on. So I want to make sure I hit enter, and then I hit enter again, and it tells me done. Good. So we should all have our diagnostics on to start. So again, we did that by going to the catalog. So first step really is we got to check our catalog. I'm going to put that right here. So check the catalog. You want to have Diagnostics on. Okay, and the reason that you want to have it on is so that you can see the correlation. Okay, so we want to be able to see the correlation coefficient, the R value. All right, so next we want to build our least square regression line. So the way that we do that, I will say it and then I'll write it. All right, so I want to hit Stat, go over to Calculations. I'm going to go with choice 4, Lin Reg. I see AX plus B. I want to point something out to you that there is another linear regression choice down below. Right, it's right here, it's choice 8. But this one is in a different format. You might use this in a different stat class that you might take later, or if you took AP Stat. I'm keeping it simple. I'm going with choice 4. I want it to look like our comfort zone slope-intercept form. So I'm going with 4 right here. Okay. So here, I want to also tell it where to look at the X and Y values. I want to make sure I tell it, well, L1, L2. That's where we stored our X and Y values. So I'm going to type in L1, so second 1, comma, second 2, that's my L2. So again, I'm just guiding it to my lists for X and for Y. Okay, enter. So here it builds my equation. So it's showing me the structure, y equals ax plus b. It's giving me the a value, the slope right here. I'm going to pull it to 2 decimal spots. It's giving me the b, right? That's my y-intercept. Other thing that I need right now is the r value. So that's the strength of my correlation, right? It's 0.97. So that is the R value that I need to pull as well. So I'm just going to write into this structure to the nearest hundredth the A and B values and transfer the R value as well. All right, to remind you of the keystrokes, we went Stat to Calculations. We picked that 4th choice. So linear regression, AX plus B. We said look at L1, L2. Okay, the equation it gave us, y hat equals the A value was about 0.21 and then X. The B value was 24.34. All right, so that was our equation. Again, we rounded the slope and y-intercept to the nearest hundredth, so 2 decimal spots. And we saw that the R value was about 0.97, which makes it seem like our data, all of our points, are almost on a perfectly straight line. Okay, so I want to overlay the least square regression line onto my scatter plot. So the way that I do that, the way that I can store it in my calculator, let me show it to you first and then I'll write it down. All right, so I'm going to repeat that last process. So I'm hitting Stat, going to Calculations. It's my 4th choice, right here. Okay, but instead of pulling up the A and B value and the R value, I want to store this equation in my function list. So to do that, now that I'm here, I'm going to hit vars. I'm going to go over to yvars. I want to pick function, so enter. I want to select where to store it. I'm going to store it as the first function in my list, so enter right there. Okay, and then I'm going to hit enter one more time. It's going to show me the same thing that I saw before, but what happened is it stored it in my function list. So when I hit y equals, I see that equation, not rounded, I see it nice and precise. So if I use my arrows over it, right, it's going to show me nice and precise that same equation that I wrote down here, right? It's just not giving it to me rounded like I took it on my page right there. All right, so first let me pull away. I want to write down those steps and then I'll show you that line on the graph. So here, little side note. To store equation, we went Stat, over to Calculations, back to that fourth choice, linear regression, right? That was the AX plus B. We went to VARS, and then over to Y-VARS, and we picked that first choice, function, and the first choice, we said store it in the Y1. Let me slide over so you can see that. Okay, so now let me go back. Again, let me show you that function right here. Okay, and if I hit graph now, it's going to overlay. So right there is my least square regression line, right? I can transfer that onto my paper as well, the best I can, right? And it shows me, again, just that line of best fit, right? It's the line that makes the sum of the squared residuals as small as possible. So let me pull this away and try to transfer this onto my paper the best I can. So about like so. All right, so there is my least square regression line. And then I'm asked to do one more thing. Calculate and interpret the residual for a height of 72.2 feet. Okay, so I'm going after the residual. Remember, that is y minus y hat. So I'm looking at height of 72.2 feet. So if I go back to my raw data over here, I can see that this must be the actual data point. So actual data value. So 72.2 paired with 46.6. So this was the X, this is the Y. This is the actual Y value. Okay, I want to figure out, well, what does my model predict? So I need to go back to my equation. Okay, right here, I'm going to plug in an X value of 72.2. So 0.21 times 72.2 plus 24.34. All right, so let's see. So 0.21 times 72.2, and then plus 24.34. All right, there we go. Enter, and we get 39.5 about. Okay, so again, I'm going after my residual. Y minus y hat, my actual y value for a height of 72.2 was a max speed of 46.6. And we're going to take away 39.5. That's what our model predicted. So a positive residual, we know it's going to be a positive residual, and we're going to get about 7.1 miles per hour. Okay, and then what does that mean? It means that this actual roller coaster's maximum speed is 7.1 miles per hour more than what the model predicts. I'm running out of room. But here we go. Okay, so the fact that it was a positive residual meant that the roller coaster's maximum speed is 7.1 miles per hour more than the model predicts. If it was a negative residual, that just means that the max speed would be so many miles per hour less than what the model predicts. All right, second page. I'm going to do one part with you and then let you do the rest of it independently. This is going to go in your packet this week as well. So I want to see this example finished. All right, so the table presents 4 sets of data prepared by statistician Frank Anscombe to illustrate the dangers of calculating without first visualizing, plotting the data. All 4 sets have the same correlation and the same least square regression line to several decimal places. So we want to make a scatter plot for each set of data, find the correlation coefficient, least square regression line, and then draw the least square regression line on each set of scatter plots. Okay, so the whole goal of doing this is really just to reinforce what we were doing, right? We want to make sure that we understand all those keystrokes. And again, we are being wary, right? Wary of when we get an R value and a least square regression line without seeing what the data actually looks like. So for this first set of data, I'm going to go to my lists and I'm going to clear out my list 1 and list 2, and I'm going to type in that data really fast. Okay, and I'm just going to quickly double check it, right? I always tell you to have this habit, so I'm going to model it for you too. All right, great. Everything looks good. I know my stat plots are set up the way that I need them to be, right? I've already checked that earlier, so I'm going to quit out. Okay, and then I'm going to go Stat, Calc, go down to that 4th choice right there. Okay, and then I'm going to go right away and I'm going to store that equation in my function list. So I'm going to hit vars. I'm going to go to yvars. Okay, I'm going to pick that first choice function and then the first choice y1, just like so, and hit enter. So my calculator already knows that it's stored in the L1, L2, right? It defaults to that. So if I stored it anywhere else, I would just have to state, like say L2, L3 if I put it in another location. So here it's showing me the slope, the y-intercept, the R value. Okay, let me go ahead and write that down. So the R value is about 0.82. My line, y hat, 0.5x plus 3. Okay, and when I hit graph right now, or let me hit zoom 9, sorry, when I hit zoom 9 right now, it's going to show me my scatter plot along with that least square regression line overlaid. So zoom 9, just like so, and then here we go, it overlays it with the least square regression line. So I want to transfer that to my little box right here, and then I want you guys to do the same thing with the other 3 sets of data. So let me go ahead and draw my picture. And overlay the least square regression line. Doesn't have to be perfect, but it should be a good rough estimate. So again, this is what I saw in my calculator. Okay, so again, I want you to finish up this activity. You're just doing that same process with these 3 sets of data, writing down the R value, the least square regression line, and the picture of what it looks like. And then I have one question for you to answer at the very bottom. And I'm saying, well, in which of the 4 cases would you be willing to use the least square regression line to predict y when x equals 10, and then explain why? So what you're going to see again in this example is 4 very different looking graphs that all have the same correlation and very similar least square regression lines to several decimal spots. Okay, so you're going to answer the question B, best of your ability, and this will go in your packet this week as well. All right, that's all I have for the lecture today. So have a good rest of your day.